You did use analysis.
Okay. It crashed when Mike did it. It crashed. Did it? Really? Because it runs it into like a negative. Wow. So that's why we tried to avoid it for a while.
Yeah, but clock goes. SQL Server.
Okay, let's get started. It's 3 o'clock, right?
I think.
All right, new faces, good. So I'll have everybody introduce themselves in just a second. We'll have Ben start talking about SQL Server TE here real soon. A few announcements, make sure everybody knows what's going on. Most important one, Big Mountain Data, coming up on October 25th. This is SQL Saturday and Big Data put together. So we'll have lots of sessions on SQL Server, lots of sessions on big data topics. We're still looking for presenters. I think the call for speakers is open for like 2 more days. If I don't get more speakers. We are trying to fill we have 10 concurrent tracks and about 6 sessions throughout the day. So that's 60 different speakers that we're trying to fill. So it's a lot of great technical content. And if you guys go look at either Utah SQL Saturday or Utah Geek Events, you'll see there's lots of great sessions already about the event coming up. So definitely go out, go register, grab a flyer, take it back to work, show other people. We want developers, DBAs, data scientists, anyone that has a vested interest in data, which should be everyone on the planet, right? Because that's what's happening every day is all the data is getting bigger and bigger and we need to deal with it. So other events coming up this weekend on September 13th, there is a big data mixer. That is this Saturday at 6 or 6:30 at the Leonardo. If you subscribe to the newsletter, which everybody should, you should have gotten a link to the Eventbrite just yesterday when I sent out the newsletter, or this morning when I sent out the newsletter. It'll say link to the big data mixer. So if you need that link, I can send it to you, or just hit me up after this and I'll show you where it is. You can go to bigdatautah.org as well, and that will have the link on there as well in the meetups. Okay. Oh, hold for announcements. For everybody online, I'm sorry, there's announcements over the hospital intercom.
Internal response team, hard and long, lower level 1 lobby. Internal response team, hard and long, lower level 1 lobby.
Okay.
Internal response team, hard and long, lower level 1 lobby.
So I know you're all in the right room because nobody got up to leave and go and answer that call. So you've all got to be data people. Other things coming up, Utah Tech Week. Utah Tech Week is the first week of October. You can go to UtahTechWeek, I believe, .com. It might be .org. This is put on by Silicon Slopes. It's just a big conference kind of to showcase a bunch of different technical content in Utah. There's going to be executives presenting and technical people, and they have a hackathon going on. It's a week-long kind of event. You go to what sessions sort of that you want to. So, yes?
How do they spell tech? I've seen spelled 10 ways.
TECH. UtahTechWeek. I'm pretty sure it's .com. Yeah. Yeah. So, and Utah Geek Events is kind of helping support that by just sponsoring and getting the word out. We may have a booth or something there. You know, we'll see. Interface Conference is tomorrow, Salt Lake City Interface Conference. I'll be there for Utah Geek Events. They'll have some good technical sessions, some good overall sessions. You can go check out their site. It's Interface Tour Utah. Just do a search for it and you'll find it. Or, again, it was in one of the Geek Events newsletters that I sent out. Other announcements. Let me think. What else is left? Who has positions open that people are looking for? Nobody's hiring?
If anybody's interested in a database developer position, I have a line on it. I don't know a lot of the details that are sent it out to us, but.
Oh, I have that one.
Do you have that?
Yeah. Yeah, give me 1 second. It's sad how many of these things they send to Ben and I.
Yeah, no.
And we don't have. There it is. Yeah, DBA SQL developer, SQL Server DBA experience, development experience, working on marketing, SEO technology. We can send you who they are. It's with ConsultNet, so they don't tell us who they are and stuff like that. So if you send myself an email or Ben an email, then we can forward that on to you. And I'll put it in the next newsletter. I forgot this morning in the reminder.
And it does lead to a full-time hire. So
Yep.
it's the job. So.
Yep. Yeah, actually, that's the one they keep talking about in Park City.
No, I think so.
Oh, there's another one.
Yeah,
Somebody
this
keeps
is all-
bugging me about Park City.
Yeah, this one's on.
Yeah. Okay. Other announcements. So jobs, the air quality competition, that's also at utahbigdata.org. That's going on right now. It's already been started. Most of the teams have already been formed. If you're actually interested in getting into a team, you can still do that, but it's about 2 weeks in now, so we're a lot later in the game. But you'll hear about all the winners and the announcements of what we're doing on October 25th at the Big Mountain Data Conference. Yes?
With respect to the Big Mountain Data Conference,
Mhm.
what are some of the major changes that have been made to the conference as far as how the sessions run?
Bigger, better, faster, more, that sort of thing. It's the sessions, we're doing it at the University of Utah Business Building where we did the code camp, so it'll be a lot larger. The sessions will still be 1-hour sessions. They'll be all throughout the day and they'll be parallel running. We'll have business tracks, executive tracks, we'll have database, science, all the different various topics. So
the size of the rooms are larger?
The size of the rooms are 80+ people per room.
Very cool.
Yeah, this site, I can't say enough good things about it, because if you went to the code camp, we held 830 people inside it without breaking a sweat. So,
awesome.
Yeah, it's a really, really nice location. You're going to love the rooms. They're all with Wi-Fi and things like that. It's really nice.
Really good AV for speakers.
Yeah, speakers, it's awesome.
That's all
Yeah.
it takes over right now.
And the setup here, it's like you don't even need a connector because they literally have all of them right there.
It's good.
I mean everything.
Are they chained to the...
They have a plate that you plug into because this is where they teach. So all of the podiums are set up like a classroom style. So everything is set up so that you could teach a class. So yeah, it's a really nice location. It's going to be a lot of fun. We're trying to shoot for about 500 people. We're currently at about 250 or so. We want to hit that 500. We want to get a higher number. There, the better the environment is. You know, the more chance you get to socialize with other people, more feedback you get. So please come out and see this. And again, if you're at all interested in data of any kind, whether it's SQL Server, Oracle, NoSQL, this is the place to be because everything will be there. All topics will be there. And you can cross and see all sorts of different data topics. Okay? Any questions on those? Okay. Let's go ahead and let you get started. Oh, no, introductions. Oh, introductions, and has anyone had a problem with SQL Server in the last month? They want to discuss, open. You have an MCM and an MVP right here, so if you have questions, he's the one to ask, not me. Problems. SQL Server users are problems?
Yeah, we can't solve those.
Yeah. So there's these great talks on performance tuning that you can look up. Will actually gave one a little while ago, and he's doing it again at this event. So let's see. So no major problems. Okay, let's do introductions. Make sure everybody knows each other, and then we'll let Ben get started. Will, you're up front. You're first. Go ahead.
I'm Will Godwin. I work for Allegiance Incorporated. That works. Anything else?
No, DBA developer. What do you do?
DBA in training. Basically, I'm a recovering software engineer.
Okay, up here.
Yelena Dimor. I'm with ARUP, database analyst.
Okay.
Chad Peterson with Enrollment.com, PD.
Tom Austin, URS, database administrator.
Okay. Lars, we'll go this way.
Lars Rasmussen with Health Equity, Database Administrator. And thank goodness for full backups. I did have a problem, but it's solved. I don't trust the SANS anymore.
You should never trust your SANS. There's a great quote I read years and years ago in one of the business intelligence things. In God we trust, all others bring data. And it's that simple. So.
Tim Lancaster, Health Equity, DBA.
Daryl Hendrickson, developer, maybe apprentice DBA. So these two gentlemen at Health Equity.
Okay. We'll help you with that. Keep going there. Back there.
Yes, ma'am. Money for forever.
Okay.
Alex Rivero, work at Alliance Health, BI engineer.
Mike?
Mike Tudor, consultant with SQL Servers, SQL Solutions Group. Sorry. And by the way, I didn't mention it. You asked. There is an opening at UTA.
Okay.
Just Speaking of problems.
Yeah, lots of opportunities there, Frank.
Still on the phone, by the way, with a Microsoft support call. Doesn't mean you do what they say. They tell you this, that, they tell you to restore a week-old backup over production. Don't do it. That's why there's no open AD.
Interesting. Okay.
My name is Wayne Hardshire. I'm currently looking for something. I was working in the state and they eliminated my position and there wasn't any other place for me to go right now. So if any of you don't have any openings for somebody who's just wonderful and good looking and all that other stuff, go give me a call.
I already took this.
I was going to say, now wait a minute, you're looking for a DBA position, right?
Keith Stout, NLinks, IT specialist. That's the more socially acceptable title, I guess, that I have.
Okay.
Ben Southward, DBA Area Laboratories.
Okay. Martin?
Martin Miller, I'm a data architect here at Intermountain Healthcare.
Ollie Martin, IT analyst at Area Laboratories.
I'm Wayne Nicole. I'm a SQL server DBA at Microsoft.com.
Trevor Smith. I'm a search consultant with Parallel HR Solutions. I've been called headhunter, recruiter, and tons of other bad things. So I won't approach anybody. I'm here to learn, but Wayne, I'll give you a card.
I was going to ask you for a card.
Absolutely.
Awesome. Okay. Pat Wright. I work for Allegiance during the day, and during the evenings I work for Utah Geek Events. I run it, take care of it, and manage all the events that you hear about. So if you have questions about those events, you can let me know. Jason, you got to introduce yourself because you just walked in, so knock yourself out.
Hi, I'm Randy Knight.
You look really different. I thought you were in another state today.
Well, I'm omnipresent. Jason Griffall, Principal Consultant at SLC Solutions Group.
Okay. All right. Ben, you're going to introduce yourself, so I'll let you go ahead and get started.
Cool. All right. And it's already going, right?
Yeah, it should be recording now.
So it shouldn't matter. Wow, green is really good on this monitor. That's okay. Yeah, this could be. I could be flat. Yeah. So we're going to talk about TDE. I'm hoping to be able to talk also about the SQL encryption in 2014 for backups. So you can use encryption for this. It dovetails well with this because we're going to be talking about the encryption hierarchy and setting it up and what is necessary for you to implement encryption inside SQL Server. So hopefully, I'm one that prefers or is okay with interaction. So if you have questions while we're talking about it, please feel free to interrupt and we'll try to manage the time as best we can. But I'd rather have your questions answered than to defer and then have you forget the question or we leave and you didn't get your question answered. So. What? Well, yeah, Jason has his own problem.
That's okay. Jason has not had to not ask a question, just interject.
Okay, that's fair too. We're all good at heckling. Pat's the best, but we're okay. Yeah, he's going to be quiet today. So this is what we're going to go over. It looks like a lot, but it goes pretty quick. Most of the stuff is going to be demo, so that you can see it actually happen and see what happens when we implement encryption. But basically, we're going to talk about TDE or transparent data encryption. How many of you guys use TDE or have been familiar with it or set it up? Or okay, so some. All right. Transparent data encryption is called that because the database gets encrypted as it sits on the disk. So while it's at rest, the database gets encrypted. When it gets read from the disk and brought into buffer cache, it is decrypted. The reason you have to have this encryption hierarchy that we'll talk about is because without that in place, the engine doesn't have access to an encrypted piece of data, right? So in order for it to decrypt it, to take it into buffer cache, it has to decrypt it. So without that encryption hierarchy, and there's many ways you can break it. Thankfully, they fixed some bugs that were logged a while ago that allowed you to break it. You used to be able to drop your certificate, which is not a good thing to do if you want your data back, because no one can decrypt it. That's the problem with transparent data encryption, is that if you do something bad to your encryption hierarchy and cannot reconstruct the encryption hierarchy, your data is gone. So you don't have much hope. So the encryption algorithms that we use are pretty standard. We have AES 128, 192, 256, triple DES, fairly standard algorithms in there. They are designated when you create the encryption key for the database. So we'll see that in a second. Encryption is performed at the page level. So if you think about a database is made up of what? 8K pages, right? Lots of them, if you have a big database. Every page is encrypted, so you don't really see a row encryption. It's not really relevant, right? So it encrypts the page whether it's empty or full. If it has one row on it, it's going to encrypt it and store it on the disk. So as you get larger and larger databases, you'll see potentially, if you have a lot of RAM, you could see some performance degradation in reading it. The data and the log files are encrypted, so it doesn't discriminate. It's not just about data. Everything that hits the log file is going to be encrypted because it goes into the database, right? So it's basically a whole database encryption at rest. So don't get confused that it's partially encrypted. Now, this next item right here in the list is important to realize. Because SQL Server has a shared TempDB, you could have 500 databases and you could have one database encrypted and it will encrypt TempDB. The reason is because, do you always get to control what you put in TempDB? Lazy spools, eager spools, work tables, table variables, they're data. It has to ensure that everything that hits the disk is encrypted. It's the way it works. So TempDB is also encrypted, so data in transit will also be encrypted so that you don't get specialized data that people mine the TempDB file and get the data out. You don't want that. So it encrypts TempDB by default by one database being encrypted. The other thing to remember about this is that when you encrypt a database and TempDB gets encrypted, even if you unencrypt or drop the encrypted database, TempDB stays encrypted until the next instance restart. Just beware. So if you've dropped it and if you're not in the habit of restarting your instance, which you shouldn't be very often, your TempDB will remain encrypted until you do a restart. So make sure you plan that in if you decide that you're going to play with it in production, and then get TempDB encrypted, and then decide that you're going to drop that database. You better recycle your server. The other thing to know is that if file stream data is a new data type in 2008, file stream is not encrypted. So if you implement a database, you implement TDE on it, and you use file stream and have file groups that are designated for file stream, store files in it, that data won't be encrypted. The reason is because it's outside of SQL Server, right? When you do file stream, it stores it on the file system. There's no way SQL can control that file, except that it has the pointer to it.
It's kind of a dumb question, but I'll ask it. So when you do like the BCP or you do a backup, they're both encrypted?
No, BCP is not, because BCP is data, right? So if I do a select statement, same thing as BCP, right? So it's gonna bring it from the disk up into buffer cache and then out.
Okay.
Yeah, always, always, always. You never get data from disk. You always get data from buffer. Encrypt, goes into buffer cache, go out. Okay. The only difference to that is that if you what they call cell encryption or column encryption, which is not TDE. If you encrypt a column, it is encrypted, whether you BCP or not. You have to decrypt it in your statement to get it decrypted. TDE is transparent, so you don't see it. You can select and think, oh, look, the database is fine, and I have data. But on the disk, it's encrypted. So BCP is not affected, but the backup is. We'll talk about that in a second. So yeah, backup is affected by this algorithm.
So when it's having to decrypt and encrypt data, especially imagine if you have a highly transactional, lots of transactions, inserts, deletes, updates, selects, what is the CPU cost on this? I mean, if you have usually, let's say you have a server with 64 cores, you have to plan for twice as many cores because of the encryption overhead.
Well, so the question is about the CPU overhead of TDE, and really the idea of that, I'll put on Paul Randall's hat, you know, and say it depends, right? Because that's his favorite word combination. The reality is that it will depend on the data and the level of encryption as far as how much CPU. But yes, it is a CPU activity to decrypt because it'll take it from disk. Obviously, that's an activity of the CPU as well. To bring it into buffer cache, but it will use the CPU to decrypt. So if you have a server that's already loaded up and you don't have much CPU to give, you'll want to think about that before you throw TDE on a large database that's highly transacted.
So I'm thinking, for instance, in terms of a warehouse and so on. So if you were trying to create these massive dashboards which have large aggregations, that implies that all the detailed data has to be decrypted before it starts doing any aggregation, any operation.
Correct.
Okay.
Yep, that's true. Yeah, and any activity that brings data from disk to the buffer cache is a decryption activity. So yep, you have to account for that. If you have a lot of RAM, a lot of CPU, fantastic. Just bring out your 2 terabyte box, your 64 core box. Oh, if you have one. Lars.
How does full text indexing play into this?
So full text is part of the database. So the database itself is encrypted. I honestly cannot tell you whether they actually encrypt the full text catalog they store on disk, because I don't know. I have never looked, actually.
My understanding for that was I had to be OS encryption in order to affect the
Okay. Because it's just words, right? I mean, that's the point. So I haven't tested it and looked, but potentially it's not encrypted. It's actually on the OS.
And it's a file outside the NDS.
Yeah, so it's kind of, it might be like file stream, but so full text data, you know, mileage may vary, but I don't think it's encrypted. I've never seen any documentation in the white paper that illustrates that it is encrypted. So, any other questions? Great. So here's the encryption hierarchy. If you don't get anything else out of this talk, this is it. This is what you want to walk away from. How it works and why. If you can enact this hierarchy, you can encrypt anything in the SQL Server. Not just TDE. You can use it for lots of things because it's about keys, and if you have the keys, you can unlock the door, right? That's the whole point. So the first key is Windows. So obviously SQL Server runs on Windows. It uses an algorithm called DP API, the Data Protection API, inside Windows. So it will use things like your machine name and your operating system version and a couple other things that will actually encrypt something called the service master key. When SQL Server starts up, you might see in the data directory a CER file. Anybody just go check back on your SQL servers and you'll see the CER file if you run enterprise. No, even on standard it actually creates one. The service master key creates its own key and stores it that encrypts from the service down. That key can be regenerated, but if you delete it, remember where that key is. It's at the root of the hierarchy. So I wouldn't delete it if I were you. So that is protected by the operating system to keep people from messing with you, right? The next piece is the service master key, and the service master key is stored at the instance level. So inside SQL Server, if you did select star from the sys.symmetric keys, which we'll do in the demo, you'll see all of this, but inside the symmetric keys, it will have a listing for the service master key. That is the first piece of the hierarchy after the OS. The next piece, and these all live, this will tell you right here where it's stored. Okay, this is at the instance level, this is at the master. Okay, so in master, you create a master key. It's not a database master key, it's a master key. And master belongs in master. So you create this master key It's calling it a database master key because it is in a database. But the reason why I say it's not a database master key is because you don't use create master key. Okay, so that master key is stored in master, and you actually will encrypt it with a password. If you lose that password, it's not as critical as losing a private key to a certificate. Okay, so you will encrypt it with a password. You'll see that in the demo, but it isn't as critical because I can recreate it and reestablish the hierarchy anytime I want, as long as I have the next piece. That next piece is the critical piece for TDE. This is actually the mechanism that encrypts. Certificate has two parts, the private key and the public key. Anybody that understands PKI understands that you need a public key infrastructure, and that includes a private key that you hold that actually does the encrypting. The public key allows people to use the encryption to send a message to you and encrypt with a public key, and you can decrypt it, but nobody else can. So if I took my public key of a certificate and I encrypted a mail message and I sent it to Lars, Lars goes, what the crap is this? I don't get it. Well, he's not going to be able to decrypt it because he doesn't have the private key associated with that public key, so it's just garbage to him. Same thing in a database. I create a certificate and encrypt it with the one above it. So remember the hierarchy, it always encrypts from the one right before it. So the service master key actually encrypts the database master key. The database master key encrypts the certificate. And the certificate will encrypt the database encryption key, which is next. Without that certificate, you're done because the private key is what encrypts. These other guys are just symmetric keys. They're just to assist SQL Server, and they're actually a key, but they assist SQL Server in the encryption. So next is the database master key, and that is actually in the user database level. So any database you want to encrypt, they implemented a new keyword, create database encryption key in the database itself, and that's stored in the boot record of the database. So that when it boots up, I know you boot a database like OS, not really, but you're going to boot your database up when you start up, and you see the little message in the error log that says starting up database. That's booting it. Okay. This is stored in the boot record, so that when it starts up, the boot record says, "Whoa, I have an encryption key. I have a problem. I need to decrypt." It will look for what it was encrypted by, which is the upper level, which is a certificate. If the certificate exists, it will decrypt. If the certificate can decrypt on the other side, so it just flows down and able to encrypt or decrypt. Once it can decrypt everything, the certificate says, "Yep, database encryption key, I'm okay." The database encryption key then says, "I'm good, I have my chain." And from then on, any query you do goes through that certificate to decrypt the data, put it in a buffer cache, and you have your data. Drop that certificate, good luck. All right, any questions on that? This is kind of big.
So you said that SQL Server instance level, that's in a file on the hard drive?
Yep.
The CER file?
It's stored in the database. It's stored inside SQL in the master database, the service master key. But that certificate is also used to get that. So a certificate is a certificate, right? So a service master key has to be used, and this DP API will take that key and use it to encrypt. Okay? So it is stored in the master database, but you won't be able to use it. You can't. I guess you could drop the service master key. I wouldn't, but yeah. The server will take care of all the service master key because it has to, right? That's the root of the encryption hierarchy. But from then on, that's where you're coming. That's where you come in, right? Protect every asset. The service master key will deal with itself. Now, one thing I will say about the service master key: how many of you guys changed service accounts passwords for your SQL servers? It's kind of important, right? Most people do not expire, right, for your passwords for your service accounts. And organizations won't allow that, right? So anytime you're in a really high government realm, you won't get the luxury of saying never expire. They always put a policy on it. So, okay, well, I'll just change the password, right? So where do you go to change your passwords? Services? Administrative tools services? Is that where you can change them? Where do you change them? Command line. PowerShell. Oh, yes! Yes! He's my friend. PowerShell. Yeah. Yeah, PowerShell is where I do it, but configuration manager. No, not from org.
Do we have the answer yet?
So whenever, even if you don't have a TDE database, you always want to change your service account passwords in SQL Configuration Manager. It's always installed whenever you install the tools. Always use SQL Configuration Manager. The reason is, if you're not aware that there's a database, you change it in services, guess what happens? That service account is part of that. Where is that on the encryption hierarchy? At the bottom, right? It's the very first thing. You change your service account password in services, and SQL Server will blow chunks all over your databases. It won't be able to decrypt your database.
You have encrypted analysis service and stuff as well.
Anything that deals with this hierarchy, you change it outside of SQL Configuration Manager, and you will blow up your SQL Server, and you'll have to go back in and redo it. So don't do that. You can recover, but you really want to do death by demo? Probably not a good idea. So the reason is because SQL Configuration Manager, when you change the service account password in there, it actually does go and decrypt and re-encrypt. You don't get that in services. Services is straight registry entry. It doesn't use WMI. It's just not a good idea. So just remember, encryption hierarchy, if you're going to change passwords for service accounts, no matter if you have TDE or not, please just use SQL Configuration Manager. It's better. Or PowerShell with the WMI. There's a SQL managed computer in SMO that does the same thing. It uses WMI, goes in, changes it, it'll decrypt. That's the mechanism SQL Configuration Manager uses, is WMI. So just be smart and help SQL be friendly to you, and you be friendly to it. You have a question?
Oh, I just thought, let's say you did that. I have an encrypted database, so I don't have to worry about that. Let's say you did that. You can't just go change the password back. Or the service account back, and then it'll start working again. You have to do something else.
No, you can.
You can, and then it'll just start to work.
Mm-hmm.
Okay.
Yep. It's just all about the password, right? So that's what it'll do. If it can decrypt the secrets, so if you do change it in services and go, now nothing works, you can go back into services and change the password back, and it will be the same because it will have that same password. So it does work well.
Same key, and then
but you wouldn't want to do that.
Well,
but if you did, you have a way out. Yeah, there's a way out. It's not an end. It's not like I gotta now lose my data. That's not the way it is. It's just, it just won't decrypt the secrets. So you have to go and do extra work, is what I'm meaning. Yeah. So you don't lose your data. Okay. So we're going to talk about the requirements, and it's kind of going around the slide we just saw, except that it is Enterprise Edition only. Started in 2008. 2005 does not have TDE. TDE began in 2008, and every Enterprise Edition after has TDE. So if you don't have Enterprise in your organization, you don't really have to worry about TDE because you can't have it. It's an Enterprise feature. The other requirements are, the next three are about the encryption hierarchy. So you have to have a master key in the database master. You have to have a certificate in the master. And you also have to have a database encryption key in the user database. That's a requirement. There's no other way to set up TDE. And then the last statement is a new, again, another keyword change that they've given to you when they implemented TDE, and that is alter database name, set encryption on. Okay, so that's something that would need to be done. You can establish the hierarchy all the way you want, But unless you alter it and set it on, it's not on, right? So, and conversely, alter database, set encryption off, and it will decrypt it. Now, if you have a terabyte database that's fully encrypted, it will take a while. Okay, so just be aware. I'll show you how to find out how well it's doing or how long it's going to be, or not how long, but how far it is in it. You'll be able to tell.
Unavailable during on and off?
No, it's all on. It's just not fully encrypted yet. Yep. So while you're encrypting, it's chugging. Right? So you're just competing for resources. So a terabyte database, and you go, I want to encrypt it. Okay. It's just gonna do it page by page by page, and until it's done, it will record 50%, 60%, blah 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 blah. When it's done, it will say 0 or 100% and say I'm done. And then you have a fully encrypted database. It will do the same thing for TempDB as you encrypt. So it will go through TempDB as well. So if it's a very big TempDB and it's got a lot of data in it, it's active, it will chug and chug and chug and chug.
So also, if that's the first one, the server, they're going to run in parallel.
They are.
One's going to kick off on TempDB and one's going to kick
Absolutely.
off on large.
Yeah, it does not go serially. It's very much parallel. So yeah, you're gonna have a load. Yeah, the server's gonna be chugging.
Because everything now has to pass through buffer cache, has it been your experience that you end up increasing the amount of memory on the boxes where you use TD?
No. Because buffer cache is unencrypted. So
yeah, you can still have the same amount of data in buffer cache.
Yeah.
What will increase is the time that it takes to get it from disk to buffer cache.
Yeah, so you can't read. I'm sorry, maybe that didn't make sense. Can you say that again?
You have to read from buffer cache every time. Buffer cache has to go down and request it from disk. This pulls it into buffer cache and returns it. That statement of buffer cache down to disk, that back and forth, that is what will take longer. But your buffer cache size doesn't really change. It's still the same amount of data. Once it's unencrypted, the name path is the same encrypted in buffer cache because the buffer cache doesn't encrypt.
Yeah.
So the size isn't the case. It's the processing between getting it off disk and getting it in.
Yeah.
So the memory transfer.
So buffer cache doesn't change.
A lot of CPU typically.
Yeah.
Is what we saw too as well.
Yeah, CPU you'll see it. But yeah, buffer cache, no change. That's why it's transparent. There really is no change.
So hardware considerations basically just CPU.
Yeah, mostly. You won't incur any RAM problem with the TD. That's not the way it would. It's all CPU. It's encryption, decryption. I mean,
Yeah.
that's a big piece.
The one caveat maybe to add to that though too is what we just said, where if you're parallelizing and it's encrypting and it's pulling every page and encrypting it, that's pulling every page into the buffer page,
Yeah.
encrypting and sending it back down. So
Right.
when you first do this, will you take a memory hit? Absolutely. You'll take a memory hit.
It's a different kind of memory hit, but yes.
But it's a one-time.
Because remember, nothing happens unless the data goes into buffer cache.
Right.
So it goes from disk into buffer cache, encrypts, puts that back. I mean, that's all activity, and it's all logged because it has to be able to recover. So yeah, not a really good thing. So first we're going to talk about some disadvantages before we go into a demo. Some of the disadvantages is that you lose database compression because the database is encrypted on disk. Whenever you back up, data doesn't go through buffer cache. It streams it from the disk out to the backup, which means it never goes through that little mechanism that decrypts. It goes that way. So you never decrypt. That means that you go to try to compress encryption. Good luck. You get a little. I mean, I'm talking 1/3%, maybe, little. So you're not really going to gain a whole lot. You're not going to go, good, I'm going to squeeze it out. In a terabyte database, you're going to get about a 975 gig backup. So if you do this, be strategic in what you need in your database when you encrypt it, but you do lose compression, so you just take your pick. Enterprise edition is required. Some people don't think that's a drawback. Depends on if you have big money in your pocket budget.
So if you've got, let's say you knew you're going to have a lot of data in the future, and you created a terabyte database right out the street. So you got it. But currently you've only got 100 gigabytes of space in this terabyte that you allocate.
Yep.
Is your backup that way?
Just data. It's the same as if I have a terabyte database unencrypted, and I have 100 gig used, and I back it up. I'll get just the 100 gig.
Okay.
Yeah.
So it doesn't
No, it doesn't encrypt all the pages. It only encrypts allocated. Yeah, so, yep. Just allocation encryption. Yep. So don't worry about that. Cell level encryption, which is column level, you get a little more fine-grained control of what's encrypted, so you could gain by using that instead. There's a lot more overhead there than using TDE because it is in the cell and you have to encrypt, or you have to use different mechanisms to get that unencrypted, so it's a little more impactful. But you do get finer grained control with cell level as opposed to TDE. Some people don't like, I mean, they want to have more control. So TDE is everything. Just transparent database encryption. Not transparent database pieces encryption. It's the whole thing. That's what you get. With one database encrypted, TempDB gets encrypted. So that could be considered a drawback. I mean, if you have a lot of TempDB activity, you have a lot of databases on your server, that could impact you because everything in TempDB is going to be encrypted. So that could be a drawback. And then the one thing I mentioned before, when you decrypt all databases, if you don't recycle the server, your TempDB remains encrypted. So that could be a drawback as well. If you have a high availability database server that says I can't take it down, you're going to have to take it somewhere in order to get that database decrypted. So let's go into demo, and this is going to be most of the presentation. There's only a couple things after this, so if we don't get past the demo, I will get past it. We have plenty of time.
Trying to say we jinxed.
Well, I'm just preparing. That's all I'm saying. That's all I'm saying, Pat. That's all I'm saying. Trying not to be pessimistic, but all right. So can everybody see that? Is that pretty big? It's fairly large. Okay. Zoom it, dude. You need zoom it for that?
I'm just saying you should.
No, not on this sucker. This is gonna. This is what? Who did what? What?
It lights to dim and all.
Oh.
I tried to dim them a little bit, but earlier we just shut them off. They didn't turn back on properly, so hold on.
Yeah. That's the other cool thing about the facility for SQL Saturday that we're going to do is it's fully loaded for that. It's really cool. You don't have to dim the whole room. It's kind of cool. Okay, is that better? Everybody see that? Okay. So for purposes, I'm just going to delete test TDE because that's the database we're going to play with. We're going to open up our script here. Come on.
See? That's what happened.
Seriously?
Seriously, we walked in here.
Wow.
The lights shut off on their own. And then they came back on, and then they shut off.
That's fantastic. Okay, well, then welcome to some fun.
That's what they said, but they're not. They said they didn't have any issue.
All right, so first we're going to just create a little database. It's not going to be very big. I think I've created it, what, a meg? Maybe, yeah, 10 meg. So not too huge, but it's enough to illustrate our. We'll go ahead and use it and create a table just to show you that there's data. Yeah, except I don't want to do analysis services there. Get out. There we go. So we'll create the table. We'll add some data to it. And to prove we have database data, we'll have the 4 fields there, or yeah, 4 rows. Now, what I didn't say in my slides is something that you really, really need to think about. We'll make this bigger so that, woo, that's kind of big. There we go. Is you should always have a backup before you encrypt it. Because we all know that hardware is totally infallible today. It's totally solid. It will never reboot on you. It won't ever have problems. The SQL Server won't barf. It's all good. So don't worry. The backup's inconsequential, and I'm lying to you. So back up your database. If you don't back it up, you're asking for whatever you get. Okay? So if your database encryption fails, you're left holding an interesting bag. Let's go make sure that we don't have a database here.
Just tweet that out. Backup is inconsequential.
No, oh my gosh, you're killing me. You're killing me, Smalls.
And it's going to go right alongside that other comment.
Yeah. Oh, dude, we got a tweet master back. Oh, God. Before we go any further, I just want to show you this, since I'm going to delete them. I'm not going to shift delete them.
See, I didn't even have to.
No, I'm prepared. I'm prepared. I know who's in the room. And I know who tweeted when I shift deleted. And it went viral. I was not happy. My Twitter account was pummeled. But I have encrypted backups here for AdventureWorks, which was 194,384. And my AdventureWorks encrypted uncompressed is 194,672. So do the math. 672 take away 384. Big gain, man. Huge. Does not much, man. Not much. 194 meg compared to 194 meg is really inconsequential bytes. Maybe 300K, not even that, like 290K. Just, you're not going to get much, okay? If I AdventureWorks unencrypted compressed, I get 45 meg. And AdventureWorks unencrypted uncompressed, 194,672, which kind of looks like the encrypted uncompressed, okay? So it looks kind of the same. So just know that you do lose when you back up or when you implement TD and try to back it up. So we're going to delete these guys. Now what I'm deleting here, notice my server cert and my server cert PBK. That's my certificate, my public key, and my private key. If I lose those, what happens?
You get a new job.
I get a new, it's an RGE, right? A resume generating event. Not a good thing to go have, right? Just, I'd rather have lunch than an RGE, so don't do that. So we'll delete those, and we'll stay in this directory so that we can go back to them. We're going to back this up, so we'll just back it up, and I knew it was going to say that because it hates me. Don't change demo machines. When you do that, you have a problem. Only when you're involved. So notice we're going to create master key next. And remember, it doesn't say database master key, right? It's the master key. Now, you can create a database master key for other databases. But in the master database, it's a master key, not a database master key. So we'll create one. Now look at this password. It's huge. Don't forget it. If you do, you're okay. You just won't be able to open the key. You'll be able to recreate it if you want, but I'll show you that later. So we're going to create, we're going to use master because we're in TDE. Use master, create master key, and look at that. See, it won't let me create two of them. So I already have one because I've done this demo before, and I didn't run TDE cleanup. So as we watch this guy right here, we'll show that we have the key, so we really don't need to recreate it. Database master key and service master key. Now I'll point out something that's really not part of TDE, but these guys right here, anytime you see a pound and ends in pound, that is a SQL Server-ism. You'll know that it is a server-based certificate or key. The server created these. If I create a master key, it will put a database master key in master, but it will mark it as pound. And that just lets you know when you're doing a select from symmetric keys that if you see pound, don't create your own with pound, because then you'll get confused. But those are identified as service or SQL Server ones. And you'll see them more if you use policy-based management. It actually has a certificate it creates in certificates that has pound. We'll see that in a second. And those are system-based, and those are for execution. So it governs those. So don't drop them, or, I mean, just leave them alone. You do your own. You don't have to put pound in front. Just create your own. Pound database master key when I created the master key, and that's just telling you it's a system key, not yours. You can create another key, another symmetric key, and name it something, but don't do your little thing. Now, we're going to have a certificate in there, and I'm going to just drop the certificate because, oh, I can't do that. I dropped the database, so I can actually drop the certificate. My server cert, because what did I just do to my private key? I deleted it, right? So I don't really have, I can back this up now and restore it, but I'm going to create me a new one. So I'm going to drop that, and look at that, it won't let me drop it. Why not? Because I've already established the hierarchy, which now I'm going to open up my TD, clean up, and clean the dang thing up. That's PowerShell. That's not going to help me. See, you did it. Demo gods do not like me today. That is the point. Yeah. Good grief, people. That's okay. It's a good thing we have time.
Should we keep it in the hall and meeting up?
They try to often. We can't say it's my event anyways that caused this, because, you know, you presented all my events.
It's true.
It doesn't really work.
Okay, well, we won't go.
We'll say it's all your events that aren't in the together.
You might be able to say that. Okay, good. No. No, that's evil. Don't do that. All right. So now I should be able to drop this guy. It doesn't like me.
What you're supposed to do is pretend that's what you wanted to happen, and you're just showing them.
Right.
Unfortunately, there's too many people in the audience. That's not true.
That's a good point. You know what? I'm going to just detach my adventure works because I know that's the reason why. Where's my detach? There we go. We're just going to detach it because this is the database that's actually causing the problem. Because I encrypted it so I could show you the backup ratios. But I normally don't encrypt that database. Yeah, I killed. Oh, I'm in the database. That's silly. Okay, so now drop my certificate. We'll take that out of the script because you don't want to drop certificates. We're going to create a certificate, and one little thing to remember is whenever you create a certificate in SQL Server, it's a self-signed certificate. You are allowed to take a .NET assembly that you have a strong name on and use that to get a certificate from it. You can take a VeriSign certificate and you can actually create a certificate from a file, which is the VeriSign certificate. You can do it however you want. Anything that is a valid PKI certificate, private key, public key, you can create a certificate in SQL and use it. One thing I'll tell you is that this is the only required field to create a self-signed certificate, is a subject. It just becomes its name. Okay? So create certificate name, and then subject equals is the only required attribute you have to use to create a certificate. Now what that'll do is it'll create a certificate with a start date of today and an end date of a year from now. It used to be thought that after a year, if you rebooted your SQL Server, the certificate would be invalid, and now your data is not useful. Well, that's not true. So inside SQL Server, it ignores expiration dates. So don't panic. We could set the certificate to expire today in 5 minutes, and I'd still be able to encrypt my database with the certificate. So don't be afraid. You should manage your certificates better than letting them expire, but if you use a VeriSign one, like you'd use for your SSL, typically you would manage it, right? Because your SSL would become invalid on the web. So you would re-up your certificate and have it expiration date out in the future. If you do that with a VeriSign certificate for your SQL servers, manage your certificates. Don't let them expire. I mean, it's okay if you do, but it just is sloppy. But we now created one, and there's text in here that you'll get these scripts, but there's little text in here that tells you. Notice I say name not like pound. Just so I can filter them out because I know that's what'll happen. And did we not? Oh, we didn't even create it. That's funny. Demo gods still like me. Okay, so we created a certificate, and now we can look at the certificate. And it says, my server cert, that's my name. Look at the private key encryption. Encrypted by what? Whatever's above it. What's above it? Master key and master. So encrypted by master key. My subject is what I had to put in there. My start date is today. GMT, by the way. Does not do time zone. It's GMT, so just be aware. UTC, GMT, whatever you want to call it. The expiry date is exactly 1 year from the start date. And then the last field Private key last backup date? No. And what happens when you don't back up your keys? Yeah, you can lose them. So don't do that if you don't have to. So now we'll go in here and use TDE because what's... Oh, did I drop it? Come on, I created it. Oh, God, are you kidding me? The demo gods really hate me, dude. You did it. You jinxed me. We'll just create it. I must not have created it. I must have created it and then I dropped it. Because I was smart. Prove that we have data. Okay, good. I think so. I may have shift deleted something more than just... So we'll come down here and we'll create our database encryption key inside test-TD because it's a user database encryption key. When I create it, I'll get an interesting error message that you'll want to pay attention to. It basically says I'm creating the database encryption key algorithm of AES 128 using the certificate of my server cert, which I just created, right? So the next one up in the hierarchy. It warns me that says, hey, you know what? You're encrypting this database, but you really haven't backed up your certificate. So you probably should. Notice the warning's not red. So it did it. It created the database encryption key, but then handed you back the reins and said, okay, here's the revolver. Point at head, pull trigger, take chances, whatever, right? So just make sure that every key, you wouldn't leave your database that's holding all your financials for the company, and you wouldn't not back up, right? You'd back it up because you want to recover it. Same thing with their certificate. You want to have your database be able to be decrypted if you ever need it. You ever want to restore your backup? It requires the key. So back it up. So we'll back it up. Got to go back into master because that's where it is. We'll back up this little guy and we'll put this actually in the right directory. And one note about this guy, you'll see encryption by password. Okay? Notice I can do backup certificate to file, which is a CER. That's just a public key. So if that's all you did, you'd get the public key, but not the private one. You have to specify with private key and specify a different file and let it back up the private key as well. Then it says encryption by password. Now you're not encrypting the key with a password. You're encrypting the backup with a password, so you can get it back. Okay? Public keys don't require backup, or private keys require passwords to encrypt. Public keys don't need it, right? Because public key is public key. Without that, private key is irrelevant. Okay? So the private key actually gets encrypted by the password in the backup. There's one other thing that you'll see in just a second. It was really fun to actually have this happen. During a demo, by the way. It was really kind of fun. When I didn't clean up, I left this file, myservercert.pbk, in that folder. When I went to back it up again in the demo, it refused to back it up because it could not overwrite that file. That's how protective SQL Server is on your backups of your private keys. Because one already existed, it said, I will not annihilate an existing backup of the same name. You can with a backup of a database, right? Backup database with an it. Not a private key. Okay? There's one other thing you'll see that'll show you a little bit more security of what SQL Server, how far SQL Server takes to secure your private key. So we backed it up. Did we back it up? We'll try. We'll try again. Oh, good. So it's saying we don't have permissions, and if I go into that folder, it's there. So we did back it up. So, but I just proved that it does actually stop you from doing that. So we're going to go look at the query again and show that it actually did log that the private key was backed up. And again, GMT. So just be aware it's using the same time structure, so you know when you look at it if that's what time it was done. If you're into auditing. Now we'll go down and we'll set the database encryption on. Now what I'm going to do here is we're going to run multiple things to show you I don't think we'll catch it in the act, but we might be able to catch it in the act of being encrypted, because we only have one table with 4 rows. How fast do you think it will really encrypt that? Pretty fast. I haven't done a big demo where I can actually show you, but it usually catches it in the act, which it did. So you can see test TDE come in and say 72.5. It's 72.5% complete. It's in a VM, so I mean it does take a little bit of time. The encryption states, I actually put in the demo slides, or in the demo text here, the encryption states. Okay, I didn't do it there. The encryption states are right here. So when you see 0, no database encryption key present, no encryption. Did I lie? Because doesn't TempDB get encrypted? The encryption state, encrypted. Whoa, 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 whoa. It says is encrypted equals 0. It's not a user database. So it won't say 1. Okay, so just get used to it. Microsoft decided that they weren't going to put 1. So it's 0. But it does say the state is 3. So 3 means encrypted. So don't worry, it is encrypted. And it's using AES 256, the strongest encryption they have. So it's a little more overhead even if you put AES 128, which is what we did. 2 means that the encryption's in progress. So if you change keys, it will re-encrypt with a new key, and you'll get a status of 4. If you decrypt, you'll get a status of 5. I mean, and so on. So just this is the states. It's out on the web on the documentation of Alter database, set encryption on, and in that DMV. So you'll see that. But now if we did our little query to show.
Emergency department, priority 1 patient. Shock trauma ICU.
We'll run this again, and we'll see that now both of them are encrypted. 1 encrypted, 3 state, 0% complete. Okay. So don't panic. So now we're going to switch, and we're going to show that we still have data. Now this is the other thing I want you to notice too. You have 2 places to find out whether the databases are encrypted. One is in sys databases. Is encrypted, right? But the database, sys databases actually has a create date in it, but they've decided to add in sysdm database encryption keys another create date. Okay? So we'll execute these 2 together, and you'll see. So here is the sys databases one. Right here, says 9, 10, 14, 56, 58, 500. In the sys database, the DM encryption, here we go, DM database encryption keys, it shows me the name of the database is test TDE. The database was created in sys databases at 9, 10, 14, 56, which validates. But then they have an encryption created column that doesn't look the same. And we recognize this hour as GMT, right? Because when we created the certificate, what hour was it? 21. So in the encrypted keys, the DM, it actually pulls GMT. So depending on which database view you're looking at on creation date, you're going to get a different time zone. So just be aware of that. Not really related to TDE except database encryption keys. If you don't have one, you won't ever query that view. Now we're going to back it up. And in the right folder, actually. So now we go out and look, and we have our test TD unencrypted, 3 meg, and test TD encrypted, 3 meg, so we know we got the same database. We didn't really try to compress it because you're going to get about 5K or more, or less of encryption. But we do have all our keys. So now we're going to switch to the second instance of our SQL Server here. So let's go to S2, and we're going to attempt to restore the database we just backed up, because we're going to want to do dev environments, maybe. So we're going to make sure we have the same version. And I believe this is Enterprise. It better be Enterprise. I'll die. Enterprise Edition. Okay, we're good. Now we'll go in here, and we'll attempt to restore file list only, just to see what's in it, so we can restore it on the new instance. Whoa, whoa, whoa. It doesn't like me that way. So it comes down and says, I can't find the server certificate with a thumbprint of this. So I'm sorry, I can't give you a file list. Why not? I'm on the second instance. What don't I have? I don't have the encryption hierarchy set up, right? It's a new instance. So I just barely created the certificate, so it can't be on the new server, because it's new. And I used it to encrypt this database, which now I'm trying to restore. It's going to say, sorry, guys, I have to abide by rules. The rule is, if I have this database, which in the boot record, what's there? The database encryption key encrypted by certificate. So it's going to look for that certificate to be ready. And that certificate doesn't exist on this server, so it's like, I'm sorry, I don't know what you're talking about. So now we're going to see if we can reestablish the hierarchy. Now remember I said that if you forget the password of the master key, it really doesn't matter? I'm proving it here because I say instance 2 instead of instance 1 in the password, and it will still let me create the master key. Will it let me create the entire hierarchy? I hate that word, by the way. Yes, it will. Because what is it encrypted by? The thing above it. And what's above it? The service. The service is fine. It says, I can decrypt my service master key, so I'm good. I create this master key with the password. The only thing the password is used for is if I want to open. Otherwise, if I encrypt it with a password, it gets stored. But the service master key is going to allow the SQL Server to actually encrypt and decrypt these keys below it, as long as I abide by the encryption hierarchy. So because the service master key is the front, the database master key is the second, it is now going to be encrypted, and you'll see. So let's create this guy. And it says, okay, now if I select from sys.symmetric keys, you'll see I have a database master key, and it's all well. It uses AES through 256, and it calls it the database master key, so we're good. So now we're going to create our certificate. Now, whoops, data. I have to decrypt it by password. And that's the password I specified when I backed it up, right? So that's important. So now if I create certificate, holy cow, now another error. What happened? Let's look at what the error message says. The certificate asymmetric key or private key file is not valid or does not exist, or you do not have permissions to it. Well, it's right there in the folder. Didn't I say C SQL data SQL backup my server cert.cer and then the PBK? Let's see if it's there. Look, it's right there. Why can't it see it? This is a good question, and this is for this. It's an Office 365, 5 PC, 5 tablet, 5 even 5 Macs. So 5 PCs, Macs, or and tablets. Office 365. So why can't it see? Why can't I create the certificate? Let's check. So we have C SQL data SQL backup. C SQL data SQL backup. Nope, same path.
Yeah.
Okay, well let's do that. Boy, that was almost worth the prize right there. Demo gods hate my guts. But I still get the same message. So no dice. So why not?
In use by the other instance.
Huh?
Is it in use by the other instance?
Nope.
No hierarchy?
Nope.
The key is just not installed?
Nope. Come on, you guys, you gotta know.
Well, master key.
Pay attention to the last phrase.
I think your demo's broke.
Guys, no, that's not the
Do
answer.
not have permission.
Or you do not have permissions to it. Why wouldn't I have permissions to it? It's on the same box.
Because he's here to create it.
Because Jason screwed it up.
They're different service account on the other side.
Correct. So the service account of SQL Server is what actually gets assigned to user, the only user, and I'll show you. So on a server where you just use the same service account, so SVC dash whatever, and it's the same service account, this would be flawless. For months, I would say years, I've done this demo until I decided I was lazy. And I went, screw it. I got a VM. I just need 2 instances. I got to do this demo now. And I installed 2 instances under NT service, the local service account, right, which is different by instance name. So it's NT service, yes, NT service, but the name of the account is MSSQL $instance name. Well, I was like, it doesn't matter. It's the same, right? I mean, it's just a local service account. I did the demo, restore, create certificate. I'm like, crap, it doesn't work. What the crap? Well, it's because this guy says, although you backed it up, owners get full control, which I don't own it, right? The service account did. It created it, so I'm not the owner. I could go circumvent that by owning it, but that's not the point. Administrators have full control. Well, this user isn't in this case, and the MSSQL has, but nobody else. Interesting. Well, when I restore that certificate, I'm administrator, right? On that box. Why can't I create the file? I mean, I'm in Management Studio, and I'm creating it. I have access to it. It's the service account to SQL that actually creates it. So the service account is not listed here. But if I did this, S2, and said it can read it, it doesn't really need to modify it, just need to read it. So if I said okay, okay, went back to my demo and said execute. Okay, so I have to give it more permissions. Good grief, people. Work with me. Oh, because I didn't do it on cert right here. I didn't do it to both. So let that be a lesson to you.
Just give it SA.
You guys are killing me.
Just change the service account on both.
I'm tweeting that one. That's just too good, man. So now that I gave permissions to both the CER and PDK to that service account, it said I'm happy now. I'm good. That's the level of security that the SQL Server takes for that stupid thing. Because it is your private key. That'll decrypt any backup. It'll decrypt any database. Now what good is it? I can take the files with me, reestablish my hierarchy because the master key doesn't care what password it is. Doesn't care what instance is on. It does care about that private key, though. That's the key. Gotta keep it secure. So what SQL does, it says, sorry, only the person that backed it up gets it. And administrators, which, how many service accounts are administered? I'm not going to ask that question. So now that we've established that hierarchy, now I'm going to go back and just take a quick look and make sure I have everything in place. And I do. I have my encrypted by master key. And now I'm going to do my little restore file list only. And sure enough, I did it. Okay. So now I can do my restore, and if I have to type any more in this demo, I'm just going to scream. Yeah, that's not going to help me. Okay, so now if I say restore test TDE from my backup directory, it comes back and says, all right, I'll back you, I'll restore you since you have the thing, and now I do my use tstd and I say I get my data back. So does that make sense? I mean, is that anything that's weird? Okay, so if I go into master, should I be able to do that? Should I be able to drop my master key?
No.
No. Should I be able to drop my certificate?
Yes.
You gotta cheat now.
I can't because it's protected. Now, prior to SQL Server 2008 SP2, as you can see that, SQL 2008 R2 SP2, that version is where they fixed the bug. If you run 2008 R2 SP1, anything up to SP2, you'll be able to drop the certificate. And unless you have a backup, you can't recover it. So at that point, the database is still alive until you restart the instance. So I'd start BCPing or SSISing or whichever tool you would like to use. But I'd start getting that data out of that freaking database before that instance crashes because your database is gone. Okay. Now they've protected you and said you can't do it because it's part of the encryption hierarchy. Even though, go look it up on Connect, Michael Hotek filed a bug, and they came back and said won't fix. Well, they fixed it. But won't fix, I guess, means fix in another language.
Yes, means no.
Right, exactly. They were just kind of, yeah.
I was just going to suggest you could scoop too.
Right. You use scoop too, so you're good. Yeah.
But can you back up from the NSA?
Yes.
Go ask them.
Yeah, so yeah, not great. So
They are on the list, by the way. So.
they're on the list of, no.
No, they're on our usual list.
So you'll, in the slides, it just has some DMVs that you'll use to detect or look at data that you have there. And then things to watch for, make sure that you back up things, make sure that you protect your certificates. And then I also allude to the prior to 2008 R2 SP2, you can drop your certificate. Just make sure you have multiple copies because, again, that private key, I can't stress it enough, that's your only prayer to get data back if you ever want to decrypt that sucker. And backups. So if you think, oh, we've dropped that database, we have backups. The certificate is kind of required to restore the backup too, so you're not safe.
So what kind of protections did you take there when you did this in bug?
So what I do is I have 2 USB keys that are under lock and key, and then one goes off-site to, I haven't done this, but that's what people recommend is a safe deposit box or something where it's somewhere off-site. So you have 3 copies of the key, and you don't need you need the password to the backup, right? So you store that where, I mean, whatever you want to do, LastPass, whatever, however you can protect that password. It's the same thing as a key, but don't keep them together. Okay, I mean, it's probably not wise to stuff them together. But there's also ways to use. I don't know if I allude to it in here. Oh, one other note: in mirroring and replication, both databases are encrypted. So if you mirror an encrypted database, the log's encrypted too, right? Log goes across, it's going to be encrypted too. So the database on the other side of mirroring is encrypted. Replication is also encrypted. That's just how it works for TDE because why? It's secure, right? That database is marked for encryption. What does replication do? Generates REPL commands, right? Insert, update, delete, and ships them across and then applies them. Well, how stupid would that be to have an encrypted database over here and replicate clear text? Makes no sense at all. So they encrypt that stream as well so that you maintain encryption across the site. Because the log's encrypted, so it goes across the same way.
Yeah, and with a lot of those, think of how you're going to create your secondary, or you're going to use to create a backup. If you decide to enable TDE after you create load shipping, still command to halt the database, so that transaction has to go across the wire too.
Yeah.
So in either case, either you're starting with an already encrypted database, or you're issuing the command after it has already started, so it has to go across the wire to authenticate the database.
Yeah, it'll end up encrypted if you're not encrypting already. Once you alter database, And that's the other reason why the database encryption key is stored in the boot record, right? Log shipping. If I back up the log, shouldn't that be in the log that I changed that property? I mean, kind of, right? So when it goes across, it'll apply that property to the database, and all of a sudden it'll start encrypting, right? This is part of the way it works. So be careful.
I keep seeing articles in the newspaper saying that 128 encryption has a flaw in it, and they figured out how to do it. And I always figure that that's probably a order that doesn't know what they're talking about.
So if it's RSA, then they beat it, but they haven't beat AES yet. So, and it starts at AES 128 and goes to 192 and 256. So typically, I mean, look at what Microsoft is doing, right? When they create TimpDB, what do they create it as? AES 256. They don't. It is a little more overhead, but it's 256 bytes of encryption. So that key's huge compared to 128, right? It's half. So if you love your data, just decide what you're willing to tolerate. If they do crack 128, it's a lot of work to go and rekey it, but you can do it. You just decide now when you encrypt it to stop the madness. But it is your choice to do lower encryption. But they haven't beat AES yet. It's still industry standard. RSA kind of sucks now. But, well, I mean, you know, I was being friendly, nice, kind of.
The reason to go to lower is overhead.
Yeah, it's just overhead. Yeah.
And it's really not enough overhead.
Yeah, it's not exponential. It's not like double the overhead. I mean, it's a bigger key, but it's the same algorithm. So, I mean, it's kind of using AES. It's just a bigger byte key, but it doesn't take double the CPU to do that. It's incremental. But some people just think, oh my gosh, it's double. So, I don't want to do that. It'll be so big. I took out of the slide on this one because I haven't been able to verify it. But in the olden days, in 2008 R2. They did say that the overhead for TDE was about 3 to 5%. The overhead for column level encryption was about 15 to 20% by decryption. So you take a hit by doing column, but again, there's trade-offs. TDE is the whole thing, so everything's just part of the engine. Column level is I've got to use this certain function, and I've got to do it to every row as it comes through the stream. It does go into RAM unencrypted. I mean, it does go into RAM encrypted, so I mean, there's just ramifications to that. The field you have to do for column level is at least var binary 128. That's a big column. I mean, when you have an int, I mean, 8 to 128, and it doesn't use all 128 every time, depending on the data, it's bigger. But really, it does impact your database when you start doing column level encryption. It is a very specific. I'm going to encrypt social security numbers. I'm going to encrypt credit card numbers, but everything else I don't care about. Okay. Yeah, for sure. Yeah, if you do a word clause, absolutely.
So that whole target data breach thing that we've all heard about was basically, I guess they used a memory scraper. They grabbed the data while it was in memory on the point of sale systems.
Yep.
Is there anything that can be done, or do you think there's anything that Microsoft will try to do in the future to protect against data in memory?
Column level encryption is your only option, and I don't think they will.
It's not even the only option though, because then the app still decrypts it at some point. That memory scanner. So if that memory scanner was on the point of sale on an ATM pad that was there, you would have to encrypt the application that runs the ATM pad.
I mean, you'd have to encrypt it on the client, or decrypt it on the client.
Has to be changed.
Yeah, I mean, so that's a pretty big impactful thing. And the engine would function totally different if you had encryption in memory. I mean, it would just be completely whacked. And you couldn't guarantee that the key isn't cached too. I mean, so there's a diminishing return when you start looking at, oh yeah, we should encrypt memory. Oh, okay. Yes, you can. And I'm sure there's people who would love to see that, but not everybody works for the NSA. And frankly, it didn't matter if it was encrypted anyway, because the guy, I mean, he took it and divulged it, so it really doesn't matter if it's encrypted anyway, right?
Just checking on actually, it wouldn't matter at all because it's still the data straight from the person's function.
Yeah, so I mean, again, so you're that, now you're dead, right? So I mean,
same thing that won't be
yeah, it's a nice thing. One last thing, who's used 2014 to encrypt a backup? Nobody? So one of the things that's fun in in SQL 2014 is now, if you have an unencrypted database, which most everybody does, you're now allowed to create a backup. So we'll create a backup here. Media options. Oh boy, I hate it when it's too small. It'll let you do your media options, and then when you do backup options, you actually have the option over here to encrypt the backup. And it hates me again. Oh yeah. This is another feature that you should take care of. I forgot about this, but notice how encrypt backup's not checked or not allowed to be checked. The reason is because encryption's really important. So what you have to do in order to encrypt your backup is you have to actually go up to media options and you have to say backup to a new media set. It will not let you append. Will not let you append. So if you're using, and frankly, it does the same thing in your command when you do T-SQL. It'll just barf on you, right? It won't keep you from checking the box. You can type the word, and it will barf on you because you didn't do a new media set. So this makes you create a new media set. So we do new media. We've complied with the rules now. Now it lets me check it. I can choose my AES whatever. And notice that it is not contingent upon the certificate, because here I can choose a certificate. This is why the encryption hierarchy is really important. You don't have to have the database encryption key, but you have to have the certificate in master. Have to. Because how else is it going to encrypt, right? That's the mechanism it encrypts the database. That's how it's going to encrypt the backup. So I can use that certificate for my database TDE and my backups of the TDE database, and I can encrypt an unencrypted backup with the same key. It's a good idea, right? Who's the security people in here? No, it's not a good idea, okay? Because then once they have one key, it's the key to the kingdom, not just to the avenue. So protect yourself however you want to. If it's policy not to do that, fine, whatever. But you don't necessarily want to use the same certificate for everything. So you'd create multiple certificates for certain things. That's where the subject comes in. Name them appropriately, right? Backup certificate. But it doesn't go in the certificate. It's just what you named it inside SQL, so you know what certificate to use when you back up or when you do your TDE. But I can specify any level of encryption here and still use the same certificate because the certificate has nothing to do with the level of encryption. It just is what encrypts it with that level. So I can choose AES 128, choose a server certificate, and then I want to script this out just so you can see it. We'll do cancel. Here's your statement. It goes to overboard because it has every option in there. So there's your statement, basically backup database to the disk with format, with a init, media name, that's required, right? New media have to happen if you were going to do it. And then demo database is the name of the database backup itself. No rewind, no unload, that's all our options in that algorithm. I never specify those, because that means nothing to me as far as I don't really care about those options. Encryption algorithm is the new keyword for backup for 2014. So encryption, open parenthesis, and then inside it, just like a move file with file name or name and file name, same thing, parenthesis, and end parenthesis, your parameters, comma, delimited. Encryption algorithm equals AES 128, server certificate equals the name of the certificate, and stats equals 10, and it lets you back it up. Okay? Now, if I took out this media, notice it let me back it up, because by default it creates a new media set anyway, it just doesn't name it. Okay? So in the dialog, it just makes you specify a media name. With the init is the new media. If you didn't specify init, it wouldn't have backed up. So that's the rule. So init, when you back up with encryption, must accompany the server certificate algorithm for backup in using encryption. So now if I go look at this, I didn't actually compress it. I didn't actually back it up in the right place either. Well, not in the place I was already at. We see test back 2492. Is that the same size as our other backup? 3184. Interesting. So TDE has a little bit of overhead when it backs up, as opposed to backing up with encryption. Okay, because I backed up a database. Oh, it wasn't the same database. I'm an idiot. Yeah, we backed up the different database because test TDE was already encrypted. So, sorry, my bad. That's why it was smaller. I didn't have the same makeup of the database. It would be the same size, actually. We could prove it, but does that make sense for backup? Any questions on the backup with encryption? I mean, it's not rocket science because you've already established the hierarchy for the TDE talk. But if I didn't establish the hierarchy, I would still have to create the master key, create the certificate, then I could back up with encryption. Okay, so that's how they dovetail. But it's going to become a pretty popular option because the one option with this, if I don't need database encryption, with the key with this is I could say with compression, and it would compress first, then encrypt. So now I get the best benefits of both worlds, right? As long as it will compress, then encrypt. So that's a nice feature. But again, this is only available in Enterprise Edition. So if you don't like that idea, go to Pass. Make sure you go to the little SQL Critical booth and just let them know they suck. that they should not leave encryption and security to just the people that can afford Enterprise. They should put, yeah, or buy another product, right? Because you can do that with SQL Redgate and with Lightspeed and stuff like that.
It's only $8.
You're still paying for something, right? I mean, there's still money going out.
Just install Dev Edition on every
on every box. Yeah, you're all good.
It costs you $50, and it's the best of all the worlds.
Yeah, and Microsoft Audit will never contact you.
Until we call them, they won't.
Until we call for them.
I thought that was true. True story. My brother works for a company, I won't tell you who. They got a letter from Microsoft Audit. They were being audited randomly. So beware. If you do that strategy, be prepared to start reinstalling what you really own. Because they care.
Be prepared to face the sales team that doesn't just have a sales engineer and the other guy is the sales engineer and the lawyer.
Yeah, having talked to somebody who actually got audited and failed the audit, it is a massive fee. And extra licensing fees, they make you license what you used. So if you ever thought, yeah, if you ever think of doing that, you might want to think twice. Even if you've never been audited before, Microsoft is cracking down. Because Oracle's eating their lunch with people who are willing to pay for exorbitant fees to pay for Oracle, and they're getting left out because no one will buy Enterprise. They'll use Dev. I've seen that too many times. And all they're asking for is to get audited, and it's not fun. It's not a good idea. Even though, hey, I got away with it. If you get away with it, it's legal, right? Well, okay. If that's your mentality, that's great. So that's it. If you want it, boy, that is bad. That is really bad. Well, anyway, that's my email, my blog and stuff like that. So that's it.
You can send it.
Now I'll make sure Pat has the slides and the SQL script. The SQL script is all inclusive, what you saw, and it also has some documentation in it as far as things that you should watch for, that you should back up your certificate, stuff like that. So,
and it's already recorded enough on YouTube anyways too, so
oh, yeah.
link that's in Google Plus, I know, then you already see it. But that way, if you can give me the link to this, then I can put that in.
Yep, I will. So we still have this guy. Did Lars get it? Oh, okay. Well, if he answered it, then he gets it.
Isn't it kind of your decision to make?
Your call.
Well, I mean, he answered it.
Which one? You're talking about the permissions, right?
Yeah. to escape.
Well, good thing the demo is over.
Yeah, that's really not great.
And
but-
by the way, come see him at SQL Saturday, Big Mountain Data 2 on October 25th. I don't think I'm going to let this session in, but maybe another.
This session has been pretty consistent on the demo.
Maybe I should let it.
Yeah, it's fun to fail. You got to fail to have people see
Can we make
what's
sure that
wrong.
we're in this session? Make sure.
No,
That's going out on Twitter.
no, you guys are killing me.
Session file, let's spot that.
Yes, you do.
It's fun to
You
fail.
learn a lot more.
Yep.
Yeah, I've presented many times where they say, okay, if the demo fails, ride through it because people learn from demos. And so I'm like, okay. And so ever after, I just haven't been really anal retentive about making sure that nothing fails because then people go, well, God, what could I run into? Well, I don't know.